Compact hybrid domain-based human recognition using face images. Abstract and augmented approach to detect persons based on face images captured under uncontrolled conditions is a challenging task. We propose compact hybrid domain-based human recognition using face images in this research. The three sets of features viz. Histogram Intensities, HI, Discrete Wavelet Transform, DWT, Double Density Dual Tree Discrete Wavelet Transform, DDDTDWT, are computed. The first set of features is extracted by HI and considered only the dominant 200 out of 256 coefficient values. The second set of features is extracted using DWT and considering only approximation band coefficients, and the number of features are only 1/4 of the original size. The third set of features are extracted by DDDTDWT and considered fifth band coefficients as features. The concluding features are obtained by concatenating all the three features which are effective and compressed. The database and the test face image features are matched using Euclidian Distance, ED, to calculate performance parameters. The results of the projected model are superior to the current techniques and also anticipated that the speed of computation in a real-time system is high as the number of features are compressed. Keywords: biometrics, DWT, DDDTDWT, face recognition, HI, human recognition. Introduction. Biometrics is used to recognize the physical and behavioral features of a person. The name biometric is resultant of the Greek terms bio and metric, where bio means life and metric means to measure. The identification method of human beings is selected from old-styled approaches with PIN numbers and passwords for its precision and occasion sensitiveness. Biometrics are categorized into two clusters such as physiological and behavioral biometrics. The physiological biometric structures are almost constant and comprise face recognition, fingerprint, hand geometry, iris recognition, etc. The behavioral biometric structures are variable over the age of period and comprise of signature, keystroke, and voice recognition. The biometrics are used in numerous applications such as airports, consumer electronics, financial transactions, physical access to restricted areas, healthcare, biometric time and attendance, law and enforcement, social access control, cloud computing, etc. Facial recognition is one of the briskly developing biometric modality as the use of smartphones and unusual computing devices rises. The foremost benefit of facial recognition compared to other biometric systems is that it is talented to use in mob identification as it does not involve the help of human beings. The face recognition systems installed in multiplexes, airports, and other public places can identify individuals among the mob to handle disaster atmosphere by enhancing security. Contribution: the compact hybrid domain-based human recognition using face images is proposed. The compressed HI features are measured as the first set of features. The compact transform domain features of DWT and DDDTDWT are considered as the second and third set of features. The last features are obtained by combining all the three sets of features. The performance of the scheme is verified by relating features using ED. The rest of the paper is systematized as follows: brief summary of the literature survey of present techniques of face recognition in Section 2. Proposed research details are given in Section 3, the proposed algorithm is given in Section 4, and Section V presents performance evaluation. The Section 6 comprises the conclusion of this paper. 2. Literature survey. The comprehensive research of current techniques using spatial and transform domains for human detection based on physiological face biometric trait is discussed. It includes an examination of pre-processing methods such as image resizing, noise removal, histogram equalization, etc., feature extraction methods viz., the spatial and transform domain techniques. The test and database images are related using distance formulae and classifiers. George Atzopardai et al. 1 proposed a method that fuses domain-specific and trainable features to identify gender from face image. Viola Jones' algorithm was applied on the input image to spot the faces, and in the next step alignment and resizing was done. For extraction of features, surf descriptors and crossfire filters was used. Surf descriptor was used to extract 51 facial landmarks like eyes, nose, etc., and crossfire filters for trainable features. The tests proved on ferret and LFW databases. Saket Karva and Vasish Chende to incorporate model-based methods like distance among dissimilar points on the face shape. These methods flop when an uncommon image is verified, and they also proposed the factor analysis method for feature extraction, which overtakes principal component analysis and independent analysis by using 4 different classifiers. Hoxie and Haifang Hai 3 proposed 2 contributions for face recognition, namely age-related factor joint task. Convolutional neural networks to address cross-age face recognition, which combines an identity judgment network with an age judgment network, and next non-linear age features are not separated from identity features. Zhaojian et al. 4 proposed a research method consisting of 2 parts, viz., facial pose pre-recognition and dual dictionary sparse representation. Contribution has better performance under low training samples. Mikhail V. Ilyushin and Alexander Lyubchev 5. The Viola-Jones algorithm used for face reputation in lengthy wave infrared radiation range is useless due to the need to manner redundant statistics at some stage in the necessary photo illustration and the usage of HAR features. Accordingly, they projected that the use parametric version of the Viola-Jones set of rules will increase the excellence of the processed thermal image in face reputation structures. Yasui et al. 6. Traditional face recognition systems grieve from numerous deviations like illumination, expression, and misalignment. In order to overcome these difficulties, 2 approaches were proposed. First one includes shape-constrained illumination pattern, SCIP, which models illumination deviation. Secondly, SCIP-based face recognition system deals through illumination, expression, and image misalignment. Yangkong Zhang et al. 7 proposed an approach by embedding a patch strategy in CNN architecture to learn effective features for FR. In this method, the image is cropped into patches, so there is no need of extra storage space. The features are extracted from patches used CNN structures. The results were experimentally proved LFW and YTF datasets. Zhang Yu et al. 8 recommended a system using neural network for face recognition. The binarization image denoising method for image denoising and noise drop to extract the peak and valley of the features. Secondly, BP neural network classifier used for information on batch read, differences and classifying facial features. Patarakaman Rangsia et al. 9 proposed nibble-based face identification based on convolution of hybrid features. The technique converts 8-bit binary pixel into left side nibble, LSN, and right side nibble, RSN, to rise speed of computation. The 4-bit LSN is changed to a number value changing among 0 and 240. Discrete Wavelet Transform is used on LSN to generate 4 bands, and only 1 LL band is considered for features. The RSN values ranging among 0 and 15. Histogram of oriented gradient, HOG, is used on RSN to generate another set of features. The concluding features are formed by linear convolution on 2 sets of features. The test and database features are related by artificial neural network to check the performance of the system. Xiang Xiaoqian 10 suggested a face authentication system based on ARM architecture design. Software development of face recognition system is taken in ARM embedded platform. Xiangen et al. 11 proposed an algorithm that can be applied under changes in pose, expression, and illumination, i.e., face recognition under uncontrolled conditions, FRU, by expressing information of personal characteristics ISS, individual stable space, and realization of ISS was done using ISNN, individual neural network. The ISS technique is matched through 12 current FR methods on 3 databases and achieved finest result. Stan Zili and Zhu Weilu 12 proposed a technique for simplifying the realistic capability of face database. The feature line passes through 2 feature points and covers more face than attributes facts, and thus increases the size of database. In attributes depiction, Classification is based on distance among attributes of an image, and the experiments were proved on 5 databases. Caixia 13, based on experimental results, proposed that results of face authentication depend not only on stationary face authentication system but also on active face authentication system and face image procurement device. Processor hardware disturb the rapidity and result of the authentication. Priyanka V. Bankar and Anjali C. Pise, 14, proposed color local Gabor wavelets, CLGWs, and color local binary pattern, CLBP. Both are capable to convert discriminative attributes resultant from spatiochromatic texture shapes of dissimilar spectral channel inside a convinced local area. The research suggested the attributes level union method in directive to mix numerous color local grain for final classification. Su Changpei et al. 15 proposed a face magnitude and angle change to improve the existing descriptors LBP and WLBP for face authentication system. The implementation consists of merely 16 boxes in the event of 8 neighbors to integrate through LBP. The experimental results proved the working on 4 databases. Mehmet Koc, and Sahan Topal 16 in this study, novel texture descriptor that utilizes curvature of edge segments had been extracted from input image. Extraction of edge segments as array of consecutive pixels and smooth-henning them to remove the aliasing effect of edge pixels. Then on computing curvature function from each edge segment and quantizing them according to curvature responses. In the final step by simply accumulating curvature values in a histogram. On the contrary to conventional texture descriptors, proposed HESC and HESC plus descriptors utilize only geometric information extracted from input image. On comparison, recognition results to well-known LBP method, and it's shown that HESC and HESC plus outperformed it up to 10% even with a lower dimensional feature vector. Muhammad Nazir et al. 17 presented a crossbreed attribute mining procedure which is reliable, precise, and adept in supervision multiscale and lighting deviation problems. The face part is mined by Viola and Jones technique. The hog is developed further by high variance attributes by means of DCT. The method is tested using KNN classifier. Fikri Malik Abdul Aziz et al. 18 presented a system which can recognize the human face correctly during darkness time. During the absence of light, it is very difficult to recognize the different human faces. Image enhancement can have defined as enhancing the image features to obtain improved image. It uses techniques such as contrast-limited adaptive equalization, histogram equalization and local enrichment. In order to determine the value, the eigenface method which uses the principal component analysis. Hamin-Moon et al. 19 offered a scheme which can implicate face recognition at longer distances. As the distance increases, the recognition rate decreases. The method resolves the change in the recognition rate resulting from 1m to 9m and then reducing the size by bilinear interpolation. The background illumination can be adjusted by histogram equalization and then applying the convolution neural network, CNN, to mine the attributes. Convolution neural network proposed in the system consist of 2 convolution layers and 2 subsampling phases and finally obtaining feature vector. In the stage of feature matching, Euclidean distance between the trained and training face features. Allah Elian and Hassan Demiral 20 proposed a system for automatic facial recognition using the Haralick and GLCM features. The methods can extract the features are obtained from GLCM, and in the second method the GLCM is converted to the matrix directly. For the feature matching, nearest neighbor and neural network classifiers are used. Preview on practical performance results. The GLCM method is superior to the linear discriminate analysis, principal component analysis, local binary pattern and Gabor wavelets. The ORL, Ferret, FRAV2D, and YaleB databases have shown very good results using the GLCM method with different number of levels. DDDTDWT al. 21 proposed face recognition based on sorting pixels using Discrete Wavelet Transform, DWT, and statistical features. The pixel values are sorted in rising order is presented and values of pixels are bifurcated into 2 portions, viz., low pixel values, LPV, and high pixel values, HPV. The DWT is used on LPV to produce LL, LH, HL, and HH. The LL band coefficients are considered for transformed features, which reduces dimensionality. The statistical measures are mean, median, mode, maximum and standard deviation spatial features from HPV. The transform and spatial features are combined for concluding features. The N is used as classifier. 3. Proposed research. An innovative compression-based face authentication approach via the hybrid domain technique is proposed in our research for the effective identification of a person. The initially compressed features are obtained by using high DWT and DDDTDWT. The final compact features are extracted by concatenating initial features. The ED is used to equate concluding features of test and database images to examine the proposed system. Face databases. The publicly available benchmark face databases with face images under uncontrolled conditions viz. ORL, Yale, Extended Yale, Jaffe, and Indian female are used to examine the proposed model. The performance of the projected model is tested by considering the different numbers of samples in the face image databases. 1. ORL database. A standard Olivetti Research Laboratory, ORL, face database covers face images captured between 1992 and 1994. 10 different images of 40 distinct individuals were captured under dissimilar facial expressions like open/closed eyes, smiling/not smiling, with/without glasses, varying lighting conditions. The face images were captured in a shady background with upright, frontal positions. The images are in PGM format and each image size is 92x119, 10 image samples of a single person are shown in Fig 1. 2. Indian female database. It has 11 dissimilar images of each of 20 different persons, totaling 220 samples. Each image is of size 480x640x3 pixels. The different facial expressions were taken for each person and image samples are shown in Fig 2 with JPEG format. 3. Yale database. It has 165 grayscale images with a GIF format of 15 persons and 11 samples per person. Each image of different facial expressions such as happy, sad, normal, sleepy, surprised, wink, with glasses, without glasses, center light, left light, right light. The samples of a single person are given in Fig 3. 4. Extended Yale database. It has 16,128 image samples of 28 persons with 9 postures and 64 brightness conditions. The face images used in the experiments are cropped and resized to 168x192. The single subject image samples are shown in Fig 4. 5. Japanese female face expression, Jaffe. It contains 10 distinct persons and 20 different images for each person totaling to 200 samples of images. The size of every image is 256x256 grayscale. The database images were captured with upright and frontal positions. Figure 5 shows all the images of a single subject which are in JPG format. Pre-processing. It is a method to perform some operations on the image in order to enhance quality in an image. The RGB images are converted to grayscale images to extract features from only 8-bit pixel length in place of 24-bit pixel length for RGB images to reduce complexity in the hardware and time consuming. The resizing the original image of different dimensions is converted to the required uniform dimensions. The images of all databases are resized to 240x320 in the proposed method. Feature extraction. The merging of a novel compressed spatial and transform domain scheme is introduced to extract effective features. 1. Compress spatial domain features. Histogram intensity, high, is plotting the frequency of occurrence of pixels for dissimilar intensities of an image is used for spatial domain features. It demonstrates the total number of pixels corresponding to every intensity level of an image. The x-axis has all available gray level pixel intensity values and the y-axis indicates the number of pixels corresponding to each intensity level of an image. The black indicates 0 intensity and 255 indicates white. The image sample and its corresponding histogram are as shown in Fig 6. Compression: the histogram coefficients which are corresponding to 256 intensity levels are sorted in ascending order and the least coefficient values of 56 levels are disregarded. The end result of high contains histogram coefficients of only 200 intensity levels which are considered as initial features and a compression ratio of 384:1. A. Image. B. Histogram. Fig 6. Histogram of an image. 2. The transform domain features set 1. Discrete Wavelet Transform, DWT, is sampled transformation and able to show both time and frequency information. It decomposes the signal into 4 bands based on a combination of wavelet filter and scaling filter 27. The transformation is engaged in the rows of an image using high-pass filter, HPF, and low-pass filters, LPF, simultaneously and sampled by factor 2 in digital image processing. The same operation is further performed on the columns to derive 4 bands. The 4 sub-band images in each level are one approximation image, LL, and other 3 detailed bands corresponding to vertical, LH, horizontal, HL, and diagonal details, HH. The 2DDWT is used on an image of size 240x320 to decompose it into 4 bands as shown in Fig 7. The LL band consists of significant information of an original image, hence it is almost identical to that of the original image and as shown in Fig 7, B. The bands vertical, horizontal, and diagonal bands consist of insignificant information such as vertical, horizontal, and diagonal edge information. The initial transform domain features are considered from LL band coefficients and discarding 3 detailed bands as information is insignificant. Compression: the LL band coefficients consist of only 1/4 size of the DWT coefficients by rejecting 3/4 of LH, HL, and HH bands coefficients which result in a reduction in a number of features and increase of speed of computation by way of compression. A. Original image, 240x320, B. DWT image, band of size 120x160. Fig 7. DWT of an image. 3. The transform domain features set 2. The transformation double density dual tree discrete wavelet transform, DDDTDWT, is used to generate the second set of transform domain features. The transformation is for denoising which performs substantially better than critically sampled DWT and also shift invariant. It has characteristics of double density DWT and the dual tree DWT. The structure of the double density dual tree DWT28 contains 2 oversampled iterated filter banks functioning in parallel, same as the dual tree DWT. The DDDTDWT is used for image denoising, image quality improvement, segmentation, motion estimation, and compensation. The 5th subband is considered and the corresponding number of coefficients is 4800 which are considered as initial features. Compression: the DDDTDWT is applied on pre-processed face image of dimensions 240x320 and considered the 5th band of the dimension of 4800 as the 3rd set of initial features and the compression ratio of 16:1. 4. Concatenation. The original resized face images of size 240x320 and dimensions of 76800 are used to identify a person. The effective overall final compressed features are obtained by concatenating initial features of high, DWT, and DDDTDWT of lengths corresponding to 200,19200 and 4800 results Indiana 24200 coefficients. The original image dimensions of 76,800 are reduced to 24,200 in final feature dimensions corresponding to the compression ratio of 3.17:1. D. Euclidian Distance, ed. The matching of final database features and test features are compared with ED is given in equation 1 to calculate performance parameters that compute the minimal space between the test and database features. If the space is small, then it indicates that the images are said to be similar. Where she and ye are database and test image features. 4. Proposed algorithm. Problem definition. The face identification system is to be developed to recognize persons for numerous recent applications. The final features are generated based on the fusion of compressed transform and spatial domain features as given in Table 1. Objectives. Human beings are recognized efficiently using face images with the variations in pose and intensities, and the goals are I. To rise peak recognition rate, PRR, and optimum recognition rate, OR. 2. To cut in error rates. Input, face images from standard database. Output, human recognition based on face images and evaluation of performance parameters. 1. The regular face image databases Viz, ORL, Yale, Extended Yale Jaffe, and Indian Female are used to examine the projected method. 2. The face images of dissimilar sizes from different databases are resized to a uniform size of 240 x 320, and also color images are transformed into grayscale images. 3. Initial features are extracted using high LL band of DWT and DDDTDWT. 4. The histogram is applied to the pre-processed face image size of 240 x 320 equals 76,800 to obtain high coefficients of dimension 256. The initial first set of significant features of 200 only are considered, which has a compression ratio of 384, 1. 5. The DWT is used on pre-processed face image and first level L band of size 120 x 160 equals 19,200 considered as the second set of initial features. The compression ratio is 4, 1. 6. The DDDTDWT is applied to a pre-processed face image and considered the fifth band of a dimension of 4,800 as the third set of initial features. The compression ratio of 16, 1. 7. The last features are obtained by concatenating high DWT and DDDTDWT initial features of dimension 24,200. The compression ratio of 3.17, 1. 8. The distance formula ED is used to find the distance between a database and test face images to examine the proposed model. V. Performance evaluation. In this unit, definitions of measuring parameters, performance analysis, and comparison results of the proposed method are discussed. A. Definitions of measuring parameters. False acceptance rate, FAR. It is the number of unapproved persons accepted ASAP proved persons given in equation 2. False rejection ratio, FRR. It is the measure of the number of approved persons rejected as unapproved persons as given in equation 3. Equal error rate, EER. It is the point of meeting of FAR and FRR values at a specific threshold value. The EER value is the compromise between FRR and FAR values. The performance of the algorithm is better if the value of EER is low. Total success rate, TSR. The number of approved persons successfully matched with the predefined database. Peak RR, PRR. It is the highest value of the TSR obtained. Optimal RR, or it is the value of TSR obtained corresponding to the intersection of FRR and FAR. B. Performance analysis. The performance of the proposed method is analyzed by computing performance parameters for the variations in the threshold values considering various standard face databases. 1. ORL face database. The performance analysis of the proposed method using the ORL database for PID and POD variations is discussed. Based on EER, PRR, and OR. It is witnessed in Table 1, that the percentage values of PRR and OR decrease with an increase in PID, whereas EER values increase with increase in PID. The deviations of percentage FRR, FAR, and TSR with threshold values is shown in Fig 8 for PID and POD blend of 10 and 30. The values of EER, PRR, and OR are noted in Figure 8. It is remarked that the values of FRR decrease, whereas FAR values increase through an increase in the threshold. The values of TSR rise with rise in threshold values. The deviations of percentage FRR, FAR, and TSR with threshold values are shown in Figure 8 for the PID and POD blend of 10 and 30. The values of EER, PRR, and OR are noted from the Figure 8. It is remarked that the values of FRR decrease, whereas FAR values increase through an increase in the threshold. The values of TSR rise with rise in threshold values. 2. Indian Females Face Database. The results of the proposed method using the Indian Females Face Database for variations in PID and POD are discussed based on parameters viz., EER, PRR, and OR. It is witnessed in Table 2, that the percentage values of PRR and ORR decrease through an increase in PID, whereas EER values increase with an increase in PID. The deviations of percentage FRR, FAR, and TSR with threshold values is shown in Fig 9 for PID and POD blend of 7 and 11. The values of EER, PRR, and OR are noted in Figure 9. It is remarked that the values of FRR decrease, whereas FAR values increase through an increase in the threshold. The values of TSR rise through rise in threshold values. Fig 9. Deviations of results for PID and POD blend of 7 and 11. 3. Yale Face Database. The performance investigation of the proposed method using the Yale Face Database for deviations in PID and POD is discussed based on EER, PRR, and OR. It is witnessed in Table 3, that the percentage values of PRR and OR decrease with an increase in PID, whereas EER values increase through increase in PID. The deviations of percentage FRR, FAR, and RR through threshold values is shown in Fig 10 for PID and POD blend of 5 and 5. The values of EER, PRR, and OR are noted from the Figure 10. It is seen that the values of FRR decrease, whereas FAR values increase with an increase in threshold. The values of TSR increase through an increase in the threshold values. The performance investigation of the proposed method using the extended Yale Face Database for deviations in PID and POD is deliberated based on EER, PRR, and OR. It is witnessed from Table 4, that the percentage values of PRR and OR decrease through an increase in PID, whereas EER values increase with increase in PID. The deviations of percentage FRR, FAR, and TSR with threshold values is shown in Fig 11 for PID and POD blend of 10 and 10. The values of EER, PRR, and OR are noted from the Figure 11. It is seen that the values of FRR decrease, whereas FAR values increase through an increase in the threshold. The values of TSR rise with rise in threshold values. 5. Jaffe Face Database. The performance examination of the proposed method using the Jaffe Face Database for deviations in PID and POD is deliberated based on EER, PRR, and OR. It is witnessed from Table 5, that the percentage values of PRR and OR decrease through an increase in PID, whereas EER values increase with an increase in PID. The deviations of percentage FRR, FAR, and TSR with threshold values is shown in Fig 12 for PID and POD blend of 5 and 4. The values of EER, PRR, and OR are noted from Figure 12. It is noticed that the values of FRR decrease, whereas FAR values increase through an increase in threshold. The values of TSR rise through the rise in threshold values. B. Proposed method comparison with current methods. The parameter PRR of the projected method is equated with current systems using the ORL face database presented by Mohanadeh Ahizid and Asif Mahmood 29 and Ziausu et al. 30. It is witnessed that the value of PRR is better in the case of a proposed method than the method presented by Ziausu et al. The value of PRR is same in the case of the projected and existing system presented by Mohanadeh Ahizid and Asif Mahmood. However, the features extracted in the proposed method are an amalgamation of compressed high, DWT, and DDDTDWT, hence the speed of computation is high in real-time implementation and also the complexity of hardware architecture is less. The technique DDDTDWT used is shift invariant and well suited for the extraction of effective features. The amalgamation of compressed high, DWT, and DDDTDWT reduce a total number of effective features which will be helpful in real-time identification systems to reduce computation time. Table 6. PRR comparison using ORL face database. 6. Conclusion. The face identification is one of the rapidly growing biometric modality as it is used in almost all consumer electronics and organization. In this research, compact hybrid domain-based human recognition using face images is proposed. The three sets of compressed features are extracted using high, DWT, and DDDTDWT. The number of features extracted from high is only 200 for the image size of 240 x 320. The DWT features are extracted from an LL band of size 120 x 160 and the number of features is 19,200. The DDDTDWT feature is extracted from the fifth subband and the number of features are 4,800. The final features are obtained by concatenating all three and the total number of features are 24,200. The test face images are compared with the face images in the database using IJERT to verify the results of the system. The investigational results show that the projected system outperforms the current techniques with discrete systems and also simulations using numerous feature types. In the future, the IJERT may be replaced by a neural network or support vector machine classifiers to improve the computation speed in the real-time scenario.